All right, so for today, what I'm going to cover is probably a pretty short video in the grand scheme of things of how to connect Access NOs to DCS. So that way you can use your input devices in more complicated ways than DCS allows. And even though DCS has a pretty good binding system for managing your controls and stuff, but Access NOs, because of its scripting language and things like that, you can accomplish a lot of things. So if you have certain hardware with maybe limitations, like the F-18, the parking brake has to be rotated and pulled in the sim in order for it to engage or disengage. Well, you can have all that happen in one button click if you don't have um, enough, buttons or the right equipment to do exactly what the in-sim cockpit demands. I'll show you a couple of examples of that. I'm not going to go into too many details on how to bind buttons or anything like that because I have other videos that cover that. And even though it's from Microsoft Flight Simulator, it works the same here for DCS. I will cover the small differences between the two, but there's not many. So with Access NOs, if you have it open, up at the top there's a little globe icon. If you go to that, that will send you to Access NO's website, and there is a big download page of all kinds of plugins and add-ons and things like that. And if we scroll down to near almost to the bottom here, let's see here. It's right here. It is plugin bridge to DCS World. So there's the instructions, and here's a zip file that you download. When you download that zip file, you'll get a zip file that when you open it, it has a folder called DCS Bridge. And if you read the instructions, it says you drop it into your Documents, Lorby Access NOs files, plugins folder. So that's what I've done. I've dragged it into there. And inside that folder, if you wanted to know, there's a little program. That's the bridge. It gives you a version of DCS BIOS. If you don't know what DCS BIOS is, it's basically a script that runs with DCS that pulls data out of uh, DCS and allows other programs to access that data. There's the instructions and then a library file that it uses to manage its connection. So once you have those installed in the right place, then you can come back to Access NOs. So normally in Access NOs, when you run it with Microsoft Flight Simulator, SimConnect will turn green and it'll find what airplane you've selected. But with DCS, it works a little differently. So what you'll do is in the upper right, you have to go into offline mode. When you do this for the first time, I recommend creating a new profile. You'll notice that I have two profiles, one for the F-18 and one for the F-4 Phantom. And so when you create a new profile in offline mode, a little app will open up and you'll get a second window. And this is the DCS bridge. And right now it has nothing because I haven't loaded an airplane in DCS, but it will shortly. There's a cog icon in the bottom left. You do this as a part of setting it up, verifying, where your DCS is installed, and I didn't have to change any of this information that's in here. It just did its thing. That's how it communicates with DCS BIOS, I think. And what we'll do now is pick a plane in DCS and kind of show you how I have things set up. So go to F-18, instant action. I'm just going to pick something simple. I'll just do Nevada cold and dark. We'll let that start up. It'll just take a second, or a lot of seconds. Like I said before, the benefits of this approach is mostly for being able to do more complicated things, like things that require multiple mouse clicks or scrolls or whatever. Or if you want to interface it with screens, which is what I do, I have a number of screens that are using Arduinos, and I've got a video on how to connect your screens to Axis and O's. And so it works exactly the same as that using a web connection. And because DCS, or not DCS, but Axis and O's runs kind of like a little web server in the background, and you can talk to it and get data from it. So that's how I populate information into my instruments. So back in DCS, now that we're loaded, I'm going to turn off my head tracking so that way that's not moving around on you, making you seasick. You'll see that as soon as I load it into the plane, now it says F-18 Hornet, and we have a bunch of information here. So these are all commands that I have pulled in to Axis and O's. So if you want to add a variable or an input, so what you can do is you say add a variable. Let's say there's information that you want to get from DCS to use it in a script or something like that in here. So what you can do is you hit add a variable and you'll get this window pop up. And there's two sets of variables. There's common variables, which are things that are related to all airplanes, such as your pilot name, DCS BIOS version, but you get latitude, longitude, velocities, airspeeds, G loads, all kinds of stuff here that you might use for a script if needed. And then the second category is airplane specific. And so this basically replicates what's in DCS itself for key binding. Is you have your upfront controller and there is the the option for turning that on. It'll tell you what that information is. In this case, for the UFC, this is actually the text that's in the top upfront controller text item. And so, you can tell that because it says string on it, so it's giving you a text item. The UFC on-off, 0 and 1, you can turn it on and off from here. I personally don't have to use a lot of those. If it's just a straight up on-off, whatever, I just bind it in DCS because that's pretty simple. But a good example would be like the parking brake. And the parking brake, has a rotation and a push in and out. So let's see if we can find the parking brake here. So I just typed brake into the filter. So here we go. So we have emergency parking brake, and so you have pull, you have rotate, and so there's multiple actions that need to occur in order for the parking brake to work. And so after you select an item, you can add that variable in, and now you have access to that variable for scripts and such. The second thing is down at the bottom is show a list of inputs. So this would be these are inputs for doing things in the sim, and it's very similar to the variables. So one way you could look at it is the variable is a thing that you change, and changing that thing can or getting information from the variable allows you to do stuff. Whereas in this case, this is an input. So that means changing it does something in the simulator. And they have slightly different names, and let's talk about that in the instruction in these inputs versus the variables. So if we go back to the instructions manual, we'll see the big difference between Microsoft Flight Simulator and Axis and O's. So when you have a variable that you say you want, it'll have the airplane name at the front, like F-18 Hornet, A-10C, and then it'll have the name of the variable here. Now, this has the state of the current battery power switch. Now, the thing to pay attention to is that's just what its current state is. In Microsoft Flight Simulator, you could just write to this variable and change its number, and doing that would also change it in the simulator, but that's not necessarily the case here for DCS. You have to use one of the input actions in order for you to do that. So this will tell you what the battery is, but if you want to set the battery, you have to grab the battery input from that second option. And these are some of the hard-coded variables he's talking about here. And let's go down. So if you want to send a command from Access and O's to DCS, then that's why you use the inputs. So if you're sending to DCS, you use an input. If you want to read information from DCS, you use a variable, and you can look at that variable information. And you can test it. So you could bring up this window, just like other stuff with Access and O's, and you can test it with ones and zeros for those that just react to those values. And those commands, the inputs, use the B prefix in Microsoft Flight Simulator. That's a B event, and so it just kind of carries that logic. So if you're used to that from Microsoft Flight Simulator and my other videos on how to use Access and O's, then you're basically just sending an event, and in this case, it's giving the CDU power, and it's writing a 1 value to it. So that's how you would do that. So for example, if we look here, this shows you the difference between the variable and the event. So in this case, what he's doing is he's checking to see if the A10C, if the battery is 0. So if equals to 0, so that means the battery's off. Then if it's off, then it does this first thing here, which is EPP battery power, which is the event or input into DCS from that second menu, and you give it a 1, which in this case would turn on the battery. If this is a 1, then it skips over to the else part and turns off the battery. So that means you could have a button that looks at the state of the battery, and your button, it's a single button push, and you just push it. If you push it, the battery's off, it'll turn it on. If it's on, it'll turn it off. And so that saves you, if you don't have a toggle switch that has 2 positions, and you just have a button like a Stream Deck or anything like that, then this is the kind of thing that you could do to make that button work without having to have a toggle switch available to you. There's so many button panels out there nowadays, and joysticks and stuff with buttons on them, that that this works out. Now in DCS, often it might have an on-off toggle option, so you can bind your button to that. But this is just an example, and I'll show you how I do the brake lever in the F-18. So let's look at that. So when we come down here, and we can see parking brake, pull on, push off. And so that's just reminding me, I have a brake lever that I can pull and push with a magnetic switch in the cockpit. But I did not model in my physical cockpit, the rotation aspect. So I just handle that with a script. So if I double click on this bind here, you'll see that it's going to a script that I made. And let's look at the scripts. So we'll go to the scripts editor, and let's get this sized correctly to fit on your screen. Okay, so in the scripts editor, you'll see I have a DCS F-18 category that I made, and we have the parking brake on. So let's look at parking brake on. So what I do is I look at the parking brake, and if it's a 0, that means that it's not engaged. And I want to turn it on. So then what I then do is I look at the pull state, and if it's not pulled yet, then what I do is I pull it by doing the input event. And you notice it has a similar name to the other ones, but it's not always the same. So you can't always just cut off the airplane name and turn it into a B event and have it work. So be careful with that. I've had that not work for me. I thought I could just pull off the F-18 Hornet part all the time, but sometimes they have a slight naming difference. I have a delay of 500 milliseconds between the rotation and the pull, and that's just to give DCS a moment to process. I have noticed in a couple cases where when I've got these right next to each other and those two interactions happen really fast, that the second one doesn't occur. So if you find that happening where you put two inputs right next to each other and the second one doesn't reliably fire, then just put a little wait in between. And so now with a single, in a sense, button push, I get both a rotation and a pull on the parking brake. And then I have another one that does the opposite. So when you're going to turn off the parking brake, you need to, you rotate it and then you push it in and then you rotate it back. So since there's 3 commands there, I have 2 waits in there. And so now if we, let's see here, I'll have to turn on head tracking for a second here. And you can see my parking brake there. Normally, you can just left click and then click and then mouse roll. And let's hide that. And I think it's Shift P or Alt P to get rid of the pilot. And then, all right, that was a quick breakaway because I forgot I had given power to my thing that controls this. So you can see how it moved in. I didn't touch it with the mouse, and so now the parking brake is off, and then now the parking brake is on. And so with my physical lever inside the cockpit, I can make those move. And so that it's just been really handy for me. The other nice part is let's talk about synchronizing the cockpit. So I have a lot of LEDs in the cockpit for all the different lights. So in the F-18, they have these, they're like annunciators that tell you the state of things, and your engine fires, APU fire. So I have these LEDs and I want them to light up and correspond to my physical cockpit. So what I do is I have a script, and that script is called Cockpit Sync. And so let's look at that. And what I do is it's kind of long, but basically it just runs through and it just checks the state of each of these items, and then I have it write to a custom AAO variable. And here's the reason why. If you have your hardware in your cockpit and you want to play both Microsoft Flight Simulator and DCS, and you want your cockpit to work with only having to write one Arduino program to manage your little display that you're using, I have a video on how to make those displays if you want to check on that in Microsoft Flight Simulator. It's nice if you write a single variable and you use that variable in your Arduino code. So I have an Arduino program, so let me go to it and I'll load that up. And so in that Arduino program, what I have it do is I have it check these standard variables. Let's open up the cockpit sync one. So I have, here we go. So like I said, I go through some more detail on how to do this in one of my other videos. But so in this, what I do is I go through and I check the state of all these variables, but it works for both Microsoft Flight Simulator and DCS. I don't have to change this code at all because the left bleed light is the left bleed light, whether it's in DCS or Microsoft Flight Simulator. The only difference is what turns that light on and off, and that is handled through this code. So I can decide what light gets turned on and off. Now in my case, because I have an F-18 physical cockpit built kind of inspired from the Open Hornet cockpit design, then everything lines up, meaning that the ready light for the weapons panel goes to the ready light. But in Microsoft Flight Simulator, maybe I want this ready light to be lit up based on, I don't know, the flight attendant's call status or something like that. So I could just change this to some Microsoft Flight Simulator variable and then have it turn on the ready light if I want to. And I don't have to change my Arduino code at all. So I go through and I just check all the lights that need to be lit up. And so I have weapons panel, spin recovery, all that kind of stuff. Now, sometimes I do have to do some kind of work on this end because you kind of have to decide, do you write code in the Arduino code to handle situations, or do you want to have the code written in Axis and O's? And the problem with the Arduino is every single time you change that code, you need to re-upload it to your little device, and I find that to be kind of a tedious process. And so I try and keep that code pretty generic and basic, and then I handle everything complicated on Axis and O's end. So in this case, it's what flap lights are lit. I have some script here, to handle that situation. Another one is the radar altimeter. A lot of instruments in the airplane are non-linear, and what that means is that the distance between numbers isn't the same. So let me zoom in here. So if we look at the radar altimeter in the down right here, so what you can see is that the distance from 30 to 50 is actually smaller from 0 to 1. So from 3,000 feet to 5,000 feet is less distance from 0 to 100 feet. And that's on purpose, so you can get a lot of detail in these low altitudes, but you don't need as much detail in the upper altitudes. But that's nonlinear. That means each number that you get from DCS corresponds to a different location in this first part than the second part, and you have to kind of play around a little bit with those values. And in my other videos where I talk about using the variable viewer and stuff like that, you can see what DCS is showing. You can manipulate stuff in DCS, look at what those numbers are. And then in my case, then I was able to make the radar altimeter line up. And it's just that in certain ranges, it has to move a certain distance versus in other ranges, it has to move a different distance. So that's why there is this kind of large if-then kind of structure for me, is I have to see what range that radar altimeter is in and then adjust it accordingly. You see here the altimeter, I just pull the common data, which is for all airplanes. I just find out what the MSL altitude is, and I set that to my indicated altitude. And that works for my altimeter. It's the same way in Microsoft Flight Simulator. I just pull the altitude and put it into the same variable, so my altimeter works the same in both items. And then in Microsoft or in DCS, the DCS BIOS reports the position of a lot of things using a 0 to 65535 scale, which has you do some math if you're going to be manipulating these into other things. I won't get into that in this video, but basically in the barometer pressure, you have to do some manipulation of these numbers to turn it into something sensible for what that number is. And then interior lights down here. There's really, at the moment, I'm only dealing with the instrument panel and consoles. I do have these, the flood, warn, caution, and the chart dials in my cockpit, but I don't have the lighting set up yet for those. So that's why they're commented out. I don't need them. And then so all I look at is the consoles and instrument panel for that. So now, how do I use this script? So if up here under scripting, when you have a profile, the F-18 Hornet, it comes with what we'll call an aircraft script. So what I mean by that is that it'll run whatever script you put. So I went up into scripting and chose aircraft script. That brings this up. and you will see I have chosen from the DCS F18 group, I have chosen the cockpit sync script. I made it a repeating script, and in my case, I set it to once every 200 milliseconds. And trying not, yeah, you can make the number lower, but in my case, cockpit lighting and standby instruments are lagging instruments anyways, and 200 milliseconds isn't a long time to wait. So I'm not too worried about those being ever so slightly behind the actual number by 200 milliseconds. If it was the trigger for firing, of course, that might be different, but not for a light or an instrument that doesn't need to have sub 100 millisecond delays. So what this does is then it kind of saves you some processing, right? Because you don't have to process it as fast if you're just doing things like cockpit lighting, that kind of stuff. So in this case, I have it run every 200 milliseconds, and so it's running, right now, and that means if any lights come on here, within 200 milliseconds, they'll show up in my physical world and line up with that. And so that's how I keep my lights and my screens up to date. You'll notice in here that I have placed, some of my commands into, or some of my inputs into here, not in DCS. And a lot of them have to do with things like, let's say, the right engine fire thing. In order to use that, you actually have to, right click to bring up this, then left click on that button in order to activate it. So that's two actions on two different objects that you have to do when your right engine's on fire. So in my case, yeah, in the real physical world, I have that same lift up, but that lift up, when I lift it up, it's not connected to anything electronic, so that means it doesn't know that it's lifted up. I have to tell it that it's lifted up. So what I do is I just have a little script that when I push either one of those buttons in the sim, it will lift up and push for me, and it actually closes it too. So let's see if I can show you that with this left one. See, and you can see how it opened it and closed it. So if I push it, opens it and closes it each time. So and that saves me, I don't have to do any sort of fancy programming on an Arduino for that lift up. So all of the switches in the cockpit that require lifting something, like the spin recovery switch here, you have to right click with the mouse and then left click on this when you're spinning in the air. Well, in my case, I just reach forward, I lift up my physical one, flip the switch, and then it does it for me. Closing the switch does it for me. So I don't have to wire that physical yellow cover to anything, so that way it knows that it's open. There's a bunch, there's more over here with a Gentry control, your gain switch on the left, things like that. So all of those exist for me in Axis and O's, and it handles whether those things are up and down. That's where Axis and O's really just solves a ton of problems for me as it relates to simplifying my physical design in the real world to make it match. You'll also notice that I have OpenKneeboard in here. OpenKneeboard is an add-on to flight simulators like DCS, and OpenKneeboard accepts has little programs that will switch what page you're on, what tab you're on in your kneeboard, or make it visible. And so you can use Axis and O's to actually execute programs. And so that's in the documentation. So I just execute a program, the remote control next page executable, every time I go to next page or previous page on the kneeboard, and then I've bound that to my, I have a scroll wheel on my center stick for my Virpil stick. And so the scroll wheel manages all of these, the visibility, next tab, previous tab, and pages on my kneeboard. So Axis and O's is great. I mean, you could do the whole cockpit in here, much like we do with Microsoft Flight Simulator, or like I do with Microsoft Flight Simulator, and not use any of the key bindings inside of DCS at all. The only issue is you cannot control your flight surfaces. So axes like your throttle axis or your stick axis, you will have to bind those in DCS. So DCS doesn't expose those inputs for use. So anything that's buttons and switches and dials and knobs and all that kind of stuff, all that can be done in Access NOs if you want to, but flight surface control cannot, as far as I understand. That's what the developer said, is it's not exposed through DCS BIOS. So hopefully that helps you understand how to get things going. And all you have to do when you want to play DCS is you just fire up Access NOs, put it in offline mode, select your profile, and then minimize it, and you're off and running, and it'll do its thing in the background while you're playing the sim.